Today, he's going to speak on China's ongoing vegetation greening and its influences on carbon water dynamics. With that, Dr. Zhang, take it over.
Okay, thank you very much. This is Yulong Zhang. First, I will thank Professor Kang Hee-sung's invitation. I'm very glad to be here to share my past work. So today the topic is about the China's ongoing vegetation greening and its influence on carbon and water dynamics. So now we are living in a greenhouse gas induced warming world. So in the last 1.5 centuries, the global air temperature increased significantly, especially in the last several decades. Even though in the meanwhile, the global solar radiation have a declining trend. So this substantial warming trend is likely linked to the increase of atmosphere CO2 that related to the fossil fuel emission. So, but vegetation can uptake CO2 from the atmosphere through photosynthesis, which can be act as a natural climate solution. So today the topic is just about the role of the vegetation in the global carbon and water cycles. Actually, since 2000, China has conducted a new forest policy and conducted 6 priority forest programs along a new total investment of $90 billion. So several forest programs, for example, like the Nature Forest Protection Program, the Green for Green program that mentioned by Professor Chen. And so all these forest programs just make China as the country with the fastest net gain in forest areas in the world since 2000. So this figure just shows the picture of the Earth's greening since 2000. As we can see that the Asian, the China and India are the most 2 greeningest placed countries. And the statistics shows that China is the largest contributor to this greening since 2000. Because as we know that vegetation can take carbon through photosynthesis, but in the meanwhile, it should consume water through transpiration. So these 2 processes, the carbon uptake and the water assumption, is usually coupled together. So this substantial greening in China may alert the carbon and water dynamics. So in this talk, I will focus on the greening induced carbon and water dynamics, both on the national scales and the large basin scales. So Yangtze River is the largest river in China and also in Asia, and the 3rd largest river in the world. So its basin area, named the Yangtze River Basin, is actually supports about 34% of China's population and contributed about 40% of China's GDP. But in the meanwhile, it is also strongly influenced by human activity and climate change. But the good thing is that the Yangtze River Basin is one of the major areas with reforestation and forest protection programs. So the substantial greening in areas may have influenced the carbon sequestration. This figure just shows the land use land cover change in the Yangtze River Basin from 2001 to 2010. And so as we can see that the green color here just shows the forest. So the satellite the product just shows that the forest area in the Yangtze River Basin actually increased from about 22% in 2001 to 33% in 2010. So with an average the annual increase of nearly 1.2 per year. And as we can see that, so the forest increasing is actually at the cost of the shrinkage of shrubland. And all the other land cover the change shows no particular trend. So based on the remote sensing data and the ecological modeling, we just show that the land use land cover change effect on the net primary productivity or NPP just shows a substantial increasing trend in the first 10 years of the 21st century. And it's about at the spatial scales, about 60% of the areas just shows positive effect of the land use land cover change on the GPP. But in the meanwhile, we also examine the climate influence on the NPP change. For example, the first figure just shows there's about 67% of the area shows a declining trend of NPP that are related to the solar radiation. And the second figure just shows the influence of temperature on NPP. As we can see that in the lower reaches of the basin, temperature just exert the negative influence on GPP. But in the high latitude areas, the temperature shows positive effects. And the third figure just shows the influence of the moisture stress. And overall, some drying event in the west areas and drying trend show the negative influence on GPP. And some of these key climate effect together, the climate showed an overall negative influence on the NPP trend from 2001 to 2010. So as a summary is that, our modeling work just shows that in the Yangtze River Basin, the land use land cover change in terms which is mainly related to the forest expansion showed a very positive influence on NPP, which is among 0.6 per year to 1% per year. But in the meanwhile, the climate just shows a negative influence, although it is insignificant. But overall, the land use land cover change shows a major effect on the final total NPP trend. So which suggests that the forest restoration in this area is actually an efficient carbon sequestration way in this area. Our further national studies with longer time also confirmed such a conclusion that the greening trend mainly related to the reforestation showed a very positive trend on the total carbon sequestration. But actually, we also identified other factors that the CO2 fertilization effect, as Professor Chen mentioned, that showed a positive effect on the total carbon sequestration. But another interesting is that during this period, China actually showed a declining of solar radiation, which is mainly caused by the atmosphere pollution. So such a declined radiation actually induced the GPP decrease in the past two decades. But overall, the vegetation structure change that reflected by the vegetation greening actually have significantly enhanced the total carbon sequestration. And besides the carbon sequestration, I also mentioned that plant take carbon at the cost of water consumption through the transpiration. So we further examined the greening effect on the water dynamics first on the evapotranspiration. So the total water consumption by the vegetation. So in the Yangtze River Basin, we show that the greening effect on the annual evapotranspiration is significant. And we can see that the widespread increasing trend of evapotranspiration in this large basin. And based on, we further calculate the water yield, which is the difference between the water input of precipitation and the water consumption through the evapotranspiration. So this figure just shows the relative greening effect on the water yield. So the red part just marks the negative effect of greening on the water yield. So we can see that for this large basin, most sub-basins shows limited effect of greening on the water yield. But for some local sub-basins, for example, the Hanjiang River Basin shows a strong negative effect of greening on the water yield. So based on this sub basin just shows an interesting declining of water yield. So we further investigated the greening effect in this area. So this figure, so the greening route here in the left map shows the route of the project in China named as the South to North Water Diversion Project, which is the largest hydrological engineering project in the world in terms of the investment to mitigate the water shortage in North China. So in short words, so the water in the Han River Basin is converted to the northern China to mitigate the water shortage there. So the upper Han River Basin, which is a subtropical basin in central China, serves as the water source area for this middle route of the diversion project. So in other words, the total water amount in this basin is essential to ensure the running of this diversion project. So here we first checked the vegetation activity in this basin during the past two decades. So we can see that this is the vegetation greening trend. for this region. So the greening trend is very significant, and this area, the forest. So the green color shows the forest area. So in the last 2 decades, the forest area expand a lot. And our final analysis just show that this greening is actually mainly related to the forest expansion in this river basin. So based on an eco-hydrological model, we studied the effect of the greening on the water yield in the last 2 decades during across this subtropical basin. So this figure just shows the water yield trend in the last 2 decades. So the red color shows the significant trend, the trend with significant area. So overall, we can see that in the lower reaches of the basin, which it actually have a strong greening trend, just showed a significant declining trend in the water yield. And our estimation shows that the vegetation greening could potentially reduce the annual water yield supply by 7.3 cubic kilometers on average, which is accounted for nearly about 77% of the intended annual water diversion volume of the diversion project. Although the diversion project the capability of holding water is not only related to the total net water yield of the basin, but it also related to the holding capacity of the reservoir itself. But such amount of the water yield decline is still significant. That will potentially influence.
2 minutes left.
Okay. Yeah, so and in the meanwhile, we further checked the greening effect on the water yield. For example, if we consider the greening effect, so the drought day increased a lot when compared to the scenario that without greening. So the take-home message here is that first, the nationwide reforestation program actually pays back. The ongoing greening in China is substantial and likely to continue in the near future, although Professor Chen mentioned several factors on this trend. And the second, the substantial greening in China appears to enhance the carbon and water cycle widely. Here we just show the enhanced total carbon uptake and the water consumption. And the last one is that carbon uptake by vegetation is always at the cost of water loss. So the potential risk of the increased water consumption by greening is actually worthy of noting in the water sensitive region, even in the humid subtropical area. Yeah, this is the major reference of this work. And the last, I will acknowledge, give my special thanks to the collaborators, including Professor Kang-Hui Song, Wen and Ying, when I was a postdoc in UNC Chapel Hill, and also other collaborators. And this work is funded by NASA Couple Cycle Science and National Science Foundation and the Chinese Academy of Sciences.
Thank you so much, Dr. Zhang. Great talk on the greening and the water dynamics.